everyone. Welcome back to our channel about becoming a ROS developer here at the Construct. My name is Rodrigo. And today we have one of our students, his name is Brennan, who's going to show us what he did for his ROS Basics project in 5 days. So, hi Brennan, how you doing?
I'm good. How are you?
I'm good, thank you, thank you. So, yes, like I said, Brennan here is going to show us what he did for his ROS Basics course, in which he has to do a project where he has to control a real robot and have it do some special things. So I'll let you explain it yourself, Brennan. So whenever you're ready, you can start sharing your screen and show us what you did.
Okay, sounds good. Thank you.
No problem.
So, can you see my screen good?
Uh, right now, not yet. Okay, now it's coming on.
Okay, great.
Yes, I can see it now.
So, first of all, I'm going to do a small demo of the code actually working.
Mm-hmm.
So, I have my main.launch function, and I will at the same time echo my feedback and my result for my odometry. So, in this project, we had three main goals. Our goal was first to have our robot find the wall, approach it, get into position, and then follow that wall on its right side for one full rotation. And while doing so, it's supposed to record its odometry, so a series of its position on its way around, and also a current distance while it is doing its loop. So to demonstrate, I'll go ahead and run my code.
All right.
My main.launch function is launching my odometry server, which just logs my odometry, my service server, which is finding the wall as it is doing currently,
Okay.
and my main function, which is doing the control object of following the right wall. You see it has found the wall. Now it is exiting the find wall and entering my final position, which is becoming parallel with the wall on the right side.
Still within the server, and then right now it starts the second program.
Yes. But, okay, so I remember I emailed you a while back, or I emailed the construct because I was having the same issue and I had resolved it. And now it's what? Now it's happening again.
Let's try and launch it again. Maybe it's
So in Gazebo, it works perfectly. And I had this happen where it would just keep on rotating.
I see.
Originally, I fixed it by reducing my rate of the messages being sent to the robot, and that allowed it to work.
Yeah, it looks like it's going forward forever. So if you, for example, launch the teleop or send a 0 command, because right now it's just moving of the wheels. Oh, actually, you can do either ROS run teleop twist, or you can do like a ROS topic pub command val 0 0. But either one. Twist teleop twist keyboard. You press tab, it should. Yeah. Yeah, and now it's going back because of, I don't know actually. All right, there it is. Now you can sort of getting into place.
Not wanting to respond.
Looks like
Eat so much more.
there's a lag that I haven't seen before. So let me ask you, in the simulation, I think there's less points in the LiDAR. Maybe you're looking at the wrong, um, you're thinking you're looking at the front, but you're not. Or have you tried this in the real robot yet?
Yes,
Oh, okay.
I actually ran it last night and it worked perfectly.
Let's try it again.
Circling for the entire time. So yeah, okay.
Yeah, but make sure you kill this, yeah. And it doesn't matter how far it is from the wall in the program, or it does.
As long as it is point 0.3, it will, or more than point 0.3, it'll approach it. So it might just see it as at point 0.3 and go ahead and enter final position.
So in here, it's the problem was that it kept going.
Yes, so the problem was that it would keep on going. Usually it would stop. See, okay. Yeah, this did not happen last night. So from here, do you think we should go ahead and look at my code and see if maybe there's just like a small issue that we
Yes, yes, yes. Let's do that, and maybe we can catch it together. Look, maybe you're doing it looking the left side. Let's see. I think it might be.
it might be lag because I did it last night pretty late, and when I teleoperated from this morning, like right before presentation, it was a bit delayed.
Hmm. All right. So let's try this. Um, let's look at it. Let's look at your code and see if might be a queue size or like the rate at which you're spinning the node. Those are the two things that usually are influencing this. If not, we'll just look at the simulation and see how that works there.
Okay. So originally, I found that when I first had this issue, it resolved it by reducing my rate from 4 to 1.
For what? Or for your rate? Yes, I think definitely. So that's 1 hertz. So that means that that program is doing it once a second. I would bring it up. I would bring it up like to say 10. Let's see if 10 makes a difference. And you said it's lining up on the right side?
Yes.
It should? Okay. So for Python, you don't actually have to compile for little changes like this. For C++, you do, but for Python, you don't. In ROS1, in ROS2, you do. But wait, because you might have the other program in 721. You might have something running. Oh, no, you're not. You're good. Yeah, that joystick loading is not normal, but let's see.
Thinking about it, it might be the increased lag because.
Well, but the lag is not there when you're moving it. I can see you move it, and I mean that's for the program is the same as like if it's coming from this program or the one you wrote. Like it doesn't. It shouldn't be able to be a difference. So let's see this. Definitely finds the wall. And now it's twisting the right way.
So it's even exiting that function at the right time. It just keeps on turning.
So do you have in your main program, so in that moment where it exits, because I saw that in your output, do you have, that is the service ending, right? Or am I miss?
Yes. So
This is your move class. Okay, let's, yes.
yeah. So my service client, when it is called, it executes here, and it does my find wall function, and then it does the final position function. So we're getting
Uh huh.
but it is finishing up the final position and it is returning from the server.
Okay, and then what would make it keep twisting? So now in this moment, the main program would start, right? The follow the wall or what or something. So
So so in my move class, here's the fine wall. It goes through it and it zeroes out at the end of both of these, which is also why I was confused.
all right, where is that? So when do you publish that 000 to stop the robot and because you know you're lined up?
Mm-hmm.
So
So okay, so because we have a while loop that is basically saying while it is not within this threshold,
and was that the distance or was this threshold?
this is the angular measurement of the minimum, and it's basically saying the minimum is within this threshold from the 180, which will be the right. Do you think that uh, because of my rate, this threshold could be too small and then it's just passing over it before it measures again?
I don't understand what the threshold is. So while not that laser min, that's a variable that you set for something, right? So probably like 30 centimeters.
Mm-hmm. So, do you think it'd be easier if I just present my code fully first so that we
Yes, yes. And then we can talk about it. Yeah. And then we'll run this in the simulation and see what happens.
okay. So the bulk of my code is in our service client file.
Uh huh.
When my launch file runs the service client, we go through here. And for a little background, I'm a mechanical engineering student, and my coding experience is all basically hobby work and research and whatnot. So if you have any major coding hits or anything at the end of this, I would really appreciate it because
Yeah,
I'm
no,
doing a
I
lot of
mean,
threading in my project, and I don't know if that had a big impact on it, but
not in Python.
okay. So when we call this function, we go ahead and run these. So we initialize our node, we set our rate, which that could be,
That could be another issue. Yeah.
and then it initializes the robot control, which is our move class, which I put all of my wall following behavior and the control behavior into the move class.
Uh huh.
Then we initialize a thread for our odom, which is basically our odom client, our control, which does the pass off between the three behaviors, and then our control logic, which is the wall following behavior. And this
Okay.
starts the control. So moving on to the control, we wait for the find wall server to be started, which at this point it will be started. It initializes our call to that server, and it stores the result in here.
Uh
And
huh.
it listens for this to be true, and then it moves on to the ODOM and the wall following behavior. So basically, in calling the service server, we move into here, where we're saying that it is executing. It again initializes the class from my move class file.
Mm-hmm.
It runs the roper move file, and then it stores the responses in here. And then after that, it will move on to the final position, store that in here.
And this is the message we saw that the service find wall is finished.
Correct.
You.
Moving on, we can move into and look at the roper move file. It's in our move class, which when this is started, we will initialize a thread for the laser and the find wall. In my program, I did threading mainly to ensure that our laser data and our ODOM data is constantly being updated to a variable in these classes.
That's a good idea.
In doing this, we start our laser, which just is a subscriber, and then it uploads it to the laser data and the laser minimum for the full thing and then for the minimum value respectively. So this is constantly being updated. So then we start the self or the find wall function after a little bit of a delay to make sure we initialize our values. And then we are listening for that to return true, and then it would break from it all. So looking to our find wall function, basically we have a couple of while loops. This one will rotate until the laser minimum is within the threshold of 0.02, and this is from the index of the minimum. So it's essentially an angle, and it looks for it to be within this threshold of plus or minus 0.02. And as long as the front value
Mm-hmm.
greater. So it rotates, and then once that is fulfilled, it moves on, and it goes forward until the front value is less than 0.3, and then it zeroes that out, and it exits this. And looking at our service server from then on, it calls our final position function, which all the final position function is it rotates again until the threshold is with the right side. The minimum is on the direct right side rather than the front, whereas that was the find wall function.
Mm-hmm.
And so once that is fulfilled, it exits the while loop. It zeroes out the angular van,
And then you
it
publish
moves
that.
forward.
Yeah. Okay.
So once that is done, the service server is completely done and it is moving on in our client. So in our control function, now it is moving on into here. I was originally using this for debugging purposes because it kept entering this, and I couldn't figure out why. I thought this was back when I was trying to figure out why it would keep rotating as well. So that's why I had the +1 to make sure it only went through this once.
Uh-huh.
And then from here we start our ODOM server or our ODOM function in here, and then we subscribe to the scan. Wait a little bit, and then it starts the wall following behavior.
I'm sorry. Where do you start your autumn? On T1.start that calls.
Start, yes.
Oh, yeah. Oh, I see. Okay.
So, and here's that function. Basically, it just creates a simple action client. It waits to make sure the server's up, which it will be at this point. And then it initializes an empty goal because this is basically just setting the goal for it to start reporting.
Uh-huh.
It sends it and then is continually listening for it to be done. So moving on to the action server, we initialize some zero values for old odometry, and we initialize the odometry class and the .32 in order to hold all of those odometry values. And then we're starting a report odom and a general control function. So this is the same way that I had the thread just for the laser data. This is for just the odom data. So it is continually going. So report odom down here is just a simple subscriber, and then it goes up here and it publishes that to these odom data values. And this is pulled in our start function, which then is initialized here.
Okay.
So this is just a simple action server on /report odom. It starts that, and then we get a call that it is ready. So once it is called, we move into here, where it initializes a 0 and an empty list for the current total, which will be added onto, and the list of odoms, which will be appended to.
Mm-hmm.
It enters here, and it continually loops through here, where we look at the distance between our old odom x and our new odom x, and that is our distance. And then to add on to the current total, we just use the Pythagorean theorem in order to find that distance, and that is added on to the current total.
Mm.
And that's published as feedback as well. And then at the same time, our list of odoms is appended that coordinate. So then when I was first doing this, I originally would just start Gazebo, I would delete the props, and I would go. So I didn't actually add behavior in order to differentiate between the wall and between obstacles. And that's something that I didn't really even think about until I watched some of the other presentations. And I figured I didn't want my work to be influenced by other people like copying or whatever. So I just kind of wanted to reflect on that.
Yeah, and we didn't ask for that in the instructions.
For that, I would probably just have it like log its initial position and then again just kind of compare some thresholds of that in order to break out of it. And then lastly, it just equates the old odom to the current odom, and then it is successful once it breaks out of that.
So you're saying there that if it went more than 5 meters, then you should break and that you consider that a lap.
Yeah, so it's 5 meters, and then there were some certain values that basically just corresponded to the initial coordinate position of it where I was starting. So it is hard-coded, which isn't exactly desirable, and I
Yeah.
will fix that in the future.
Okay, and all right, great, very very clear explanation and quick.
Then moving on to the wall following behavior, which is
Yeah.
our control logic. I probably, again, in cleaning up my code, would have moved this to the move class as well. And these are just things I'm reflecting on.
Uh-huh.
T3 dot start here, that is our control logic. And it is simple control logic where it just looks to the distance on the right side. And if it's larger than 0.275, it moves closer to the wall. If it's less than 0.225, it moves a little further away from the wall. If it's within those values, it goes straight. And if the front value is a little less than 5, then it starts to turn.
Mm-hmm.
So, yep. That is the code.
I'm sorry, you broke up a little bit. What was that?
So, yeah, that is the majority of the code. Yeah.
All right. So let me say first of all, good job, and then I want to say that I'm also a mechanical engineer, so I understand your concern there, but don't worry too much about it. Now, let me ask you: did you also do this for C++, or what is your reasoning? I ask this because of the way you're doing those threads. What is your reasoning behind doing that? Did you experience a blocking of a callback or something like that? Why did you do that in that way?
So I was having a hard time in basically making sure that my laser data or my odometry data, whatever, was constantly being published throughout the entire project. And I don't know if that's more of kind of my understanding or that I just found that having a thread and just starting it right away so that it's continually going throughout the whole project, I just found that to be a little easier to wrap my head around.
Okay. No, if it's easier, it's fine. But for most people, it's the threading concept, especially in Python, is a little bit more complicated because you don't need it, right? You said that your atom and your scan wasn't being continuously published. They are. Well, in case of a gazebo, the scan in atom is published by this gazebo, by the simulation, all the time. And in the case of the robot, is by the robot itself. What you might have problems with is accessing that publishing, so with your callback functions. And in C++, doing for example, doing a callback for your scan and then trying to do something else while it's doing that, you experience a blocking, so you don't get those values. So that's why I was asking that. But if it was easier for you to wrap your hand around, that's fine. Now, I can see that you have 4 programs there in your SRC. So you have your action server, your service server, your service client, and the move class. So where do you, I'm assuming your service server is launched from the bottom one there, the service server.py, and you call it from the service client. So if we open up the server, you have it open right there. So in here, where do you make your client call to the server? Must be like the first thing.
Right in here.
Yes. Okay. So that's fine. Well, request and the proxy. Okay. So, and then you go on to do the control logic in this same program.
Yes.
Okay.
Like I said, I probably would have moved it to the move class.
Right. That's what I'm getting at. Yes, you're right. So for me, it's a little bit confusing because you can. How I think about it is to have a service server and an action server, which is running by themselves, and then you can create a client for both servers, like a client for a service server and for your action server, and then do whatever you want in that same program. So maybe that's the one of the issues that we were seeing for the service server. So so you have once a service is done, you get a result, right? So you get a failed or a there it is. Okay, so maybe this result is like a failing, right? so it's not returning as a success, and that's why it's uh, still turning. But I don't know. But my suggestion would be that to clearly separate uh, the server. For example, I don't. So your main what you're saying is that real robot service client.py, you were gonna trying to move it into the real robot move class. Is that what you were saying?
More so just moving the control.
Just that, yeah. Okay. And then,
In saying that, do you think that, such as in like a class file like this, would I have this as its own function?
uh,
Just the service client and like the ODOM client action for the client?
yeah, you can just create the client and call it at the beginning, and then that's it. So what I wanted to ask you as well in here is so in the robot, so you have some rates set up, so some ROSB dot rates, and we saw that it was 1 hertz. So I wanted to see how that 1 hertz behaves in the simulation. So since we are already at a time with the real robot, I can see we got 1 more minute. We can disconnect from it, and let's launch the simulation with the rates that you had for the simulation, because you told me you moved it. And let's see that, how that does its thing.
And you said for small changes, we do not have to change those.
You said you had to delete some. Oh, you already did it.
So I would either delete all of these, or I would just kind of move it.
Move it. All right. Otherwise, it'll just go to an obstacle. Okay. And then after this, I'm going to ask you to take a look at that main launch. Okay, so that says you don't have an attribute laserman. Maybe you have to change the amount of points you're receiving, because I think in the simulation you only get half of what they are in the real one. Maybe, I don't remember.
Yes, this is weird because even simulating in Gazebo this morning, I didn't run into that issue. Think.
Just launch it again. Let's see.
I did find I had an issue this morning where I had to relaunch the Gazebo.
Sometimes Gazebo, yeah, takes a while. But maybe that means that you were not getting the scanner. So launch the simulation and see if you're getting the scan topic. Oh, it's going to take a little while. Yeah, all right. Now you should be getting it. Yes, you are. Launch that again, because if it works in the simulation, there's nothing that I just saw it worked in the real robot. There's nothing that should be different. There you go. Yeah, that was probably a timeout thing for Gazebo. Okay, so in this part, the service is going on. And can you tell us in the moment exactly where the service is done?
So I actually added a little delay, and we'll get the.
Yeah, I saw like a 2-second thing. Yeah, I saw that.
So right now it has ended. The action server is starting. Now it is following the wall. And I find that really weird because I even remoted into the real robot lab last night and just tested it, and no issue. It just
Right. No, I think this is a rate issue. Because for me, when I look at 1 hertz, that sounds too slow for me. That sounds like that whole program, it would just do it once a second. So it's like, so it makes sense that it would just go over, but I don't know why it keeps doing that. And that's just a matter of going through carefully to see where that's happening, adding prints everywhere. But yes, I think the only thing here was to get right the rate at which your program is spinning, because at the end of the day, there is a lag, right, between, because you're in America, I'm assuming, and we're in Spain. But like you saw, that teleop, that arrives as quick as, fairly quickly, right? And that's a ROS program, the same as yours. So it makes no sense that one would and the other wouldn't, unless the one program that is failing isn't spinning fast enough. So that's why I told you at 10. But then I saw that you had 2 rates defined in that same program. So I didn't really get that. Is there a reason why you did a ROSP rate and then a ROSP rate in the main? So in here, in your class, you define your ROSP rate, right? And then at the main, you also have. Oh, I thought it was the same program. I'm sorry. Oh, yes, it is. So here, right, here you have a rate, and then you have another one here. So where's your ROSP sleep? So you have that rate. Oh, there it is. While state result rate sleep. Okay. So I think the bottom one is extra. So you can delete that and it would still work. Maybe I'm wrong, but what I think is that it's still, because it's in your class, right? So it's doing it within it. So maybe that's another source, because it's sort of getting confused there, because in the main it just runs that once and it sets that rate to something, and then you have it something else. And basically what smells to me is that the rate was weird. Now, it would be interesting to know what you did for, you said you tried it last night and it was working. I'm saying it could be the robot, right? Could be that the robot broke, but that's unlikely, because if that's like 12 hours difference. So that's my main guess. Other than that, there's nothing else that would make it continuing to to spin, especially since we saw that message exiting whatever you have that, and then you say stop publishing, and then you publish that. Maybe it's going. I mean, it's a slow rate for a program, but it's quick for us, so we don't really see it stop and then continue spinning. So that'd be a clue as well. Um, so basically, those are my main comments. And the other one, I think you might have named in different programs. You do like a start function, and then in another program you call it the same. So I used to do the same until it was just too much, and I didn't know which function I was referring to. But that can be mitigated by the fact that I really liked that you do your robot move class, and you're using everything from there. So you're taking in another program, I think your server or something. You're using that class, so that's really nice because you're only taking one class, and then you're taking the functions from there. So that would be fight against naming a lot of your functions: start, stop, blah blah blah. So, I see that gazebo bash. Is that to launch the simulation?
Yes, so I did a lot of debugging because I entered midterms, so I started getting super busy and I had to put it down. But when it was first not working in the little robot lab, I had really no clue why. So I started debugging by adding like little log values, like
Mm-hmm.
right, and I had numbers. So like here I had in my control, we started here. I started logging certain areas. So like if it's logging 2.1, I know that I'm in my control logic for sure, and I know if it's getting stuck in that one point.
See, I think
All these different areas I had.
you in that program you have something less than 360. So you're looking at two values and 180. So in here, self data of 360, you're considering that to be the middle, right?
Correct. Yep.
And self data 180 is the right. Okay. So then that assumes that the simulation has 720 values for the scan and also the real robot. Something tells me that that's not the case. But I could be wrong because we've been updating this course, and a lot of people were having difficulty looking at the laser scan from the simulation and then seeing that in the real robot it was double that. So I think that might have been changed because it's working in the simulation and you're running this program. So that's okay. So yeah, the main thing that I would say is to pay attention to that rate, because it's the only thing I can see from here that it might be causing that issue.
And it could be that in multiple of like in the client I have it as one.
Yeah. So yeah.
Maybe I'm setting it in these.
Right, and you have a lot of, so in each one you have a rate. So maybe you had them all lined up at some point, and then you changed one and you forgot to change the other. Maybe that's the reason. Let me ask you one more thing. It's running right now, right? You didn't kill anything.
No, I didn't.
So probably it's okay. Yeah. Is there a moment where this stops, or it would just continue going, and what stops is the odometry server?
Yes, the odometry server stops.
So at one moment we should get, oh yes, we should get a returning of.
It did. I didn't set the. I had it stop and I had it returning the feedback.
The current total. Yeah, that's.
But in order to see the result, I had it where you had to echo that.
Okay. So right now, if you do a ROS topic list, we won't see that because it's done, right? So we wouldn't see. So if we do ROS topic list.
The /record odom should be.
So it's still there. So the server is still running. So let's see if we can echo that result. Maybe it's just one time after it's done, but Yeah, it's just one.
running.
Yeah. So in this also I would recommend, if you're not gonna use something, for example, you say, all right, return the autumn, and you have what you need. Do a ROSB shutdown signal or something. It's a ROSB dot shutdown or something for the node you want, and that's why it's also a good idea to separate nodes in each program, because in here you can just say, oh, in your server, once it's done and you do the result, kill this program, and then it doesn't interfere with other things.
I could set like a ROSB.shutdown.
Yeah, so here you could do like a self.rosb.shutdown or something. I forget it, especially, or maybe not self, something like that. Yeah, is shutdown. Yeah, shutdown hook. No, shutdown hook is for Control C. The other one is just shutdown. And at that moment, you get or you can do like a while not success, going, and while success, kill it. So that's another thing. But other than that, I mean, we're still working in the simulation. It was just that matter of finding the difference between the simulation and the real robot, which is quite important once you want to make it work in the real robot and you don't understand why. And this is when the rate starts making sense, right? Because in the beginning, while you're doing things just with one way, and here you have a rate, and I don't really understand what it was for, so I just put it the same way. Also, for example, the publisher queue size, I don't know what that means. I just put 10 every time, unless I need to expose myself to a situation where the queue size needs to be modified. And in this case, where the rate of your program is the difference between the program working and not working. But yeah, is there anything else you want to mention? Let me ask you, what part was the most challenging? Was it the threading, or implementing a service, or the action, or just the main program?
I think originally implementing the wall falling behavior was the most difficult part to me, because when I did the action server and the action client, that honestly I just kind of implemented it, and that worked
Uh-huh.
smoothly. But I think trying to actually figure out how I wanted to do this control logic was really challenging to me, because originally I wanted it to both sense the distance, yeah, but I also wanted it to look at the index of the minimum, and if it is like less than 180, so less than to the right,
Further, yeah.
it is closest, so it needs to move far away. But I kept running into difficulties with that and decided to just do the distance. So like you could see where I had it originally.
Okay. All right. And so my suggestion for your next course for ROS at the construct would be, if you're doing Python, start the simplest way you can. Why? The reason I'm saying this is because, for example, for me, threading is really hard to understand. And if I don't have to use it, and I know I don't have to use it in Python for ROS, then I won't. I'll just do a subscriber, and then I'll have a callback on that subscriber, and then I'll do things in that callback and check if it works, And because maybe this introduces other things that are a little bit complicated and might get you lost. So that's the other thing. But if you're planning on doing the C++, keep with this mentality, because you do need to do threads in C++, because you would get a blocking callback in that scenario. And that's the way just the programming works for each language. But yeah, I mean, other than that, do you mind stopping sharing your screen so we can just kind of look at each other here? All right. So Yes. All right. So, Brennan, congratulations. It's a well done project. I mean, I'm a little bit tough all the time with all the students just because I've seen a lot of them and I kind of know where things might be going wrong. But other than that, um, your program does what it's expected to do. And why we do this is to make sure the students took something out of it, and you can really tell if someone really learned by doing this presentation, and I can tell you, it's obvious. You can tell if people worked hard on it or not, or they didn't learn anything, or just copied it from somewhere. So yeah, all those are all my questions, and congratulations again, Brennan.
Thank you.
All right.
I'm working right now on like the navigation course and whatnot because in research, in undergraduate research, I'm trying to implement like sensor fusion of small RFID NFC tags and a LiDAR.
Uh huh.
And so like I'm pretty over my head, but I'm trying to figure it out.
RFID tags for navigation.
Yeah, so I have some TN5180s.
Mm-hmm.
They have a read range of like 10 centimeters, so it's not much, but it's more of a conceptual proof of concept.
That's interesting, but I don't understand. What are you trying to do with those tags? So you're gonna set them somewhere, and the robot's gonna see them and localize itself because of that.
Mm-hmm. So originally the project came out of trying to develop planogram compliance using NFC tags because of their unique IDs. So the
Ah,
first idea is to do SLAM with just LiDAR, but then also when it detects these, use that to kind of localize itself in like a commercial environment, like a hardware store.
yeah.
And then the main idea would be to then move to a certain location and take a picture and be able to like uh, look at the similarities between like a model planogram and what's actually there.
A model what? I'm sorry.
So a planogram is the term for how products are laid out on a shelf in like a store.
Ah, okay,
So
okay.
like manufacturers or like the supplier usually send one to a store and be like, hey, I want my best product right at eye level.
So that spot is static. It doesn't move.
Mm-hmm.
Then it doesn't. That goes back to the. I mean, if you know, and if the warehouse you're in is not too symmetrical, or it's not just a square or something that makes the robot, for localization you need like features, right? You need to know. So if you have that, if you have a map which with just a lidar, you can do a waypoint scenario, which we explain in our course. So keep going with that. Um, that you can call waypoint. You can create a program to go to a waypoint and do something. Take a picture. I don't know if you have an arm, try and grasp something, whatever you want. So I recommend you looking into that because you might get away without using the tags, but the tags might add cool things. And you're saying you want to do the sensor fusion, so that
Yeah, I've been trying to look into like the Kalman filter.
right, the Kalman filter and robo localization. So you might see you're saying about fusing like the lidar and these tags somehow.
Mm-hmm.
Right. So that's interesting. That would maybe there's a really quick, a lot quicker localization because I can think of a scenario where, for example, uh, and especially in a warehouse where things are very similar to the robot, you might think that after localizing and after doing its own thing, because sometimes you can tell the robot where it is, and sometimes you have to kind of move it around for the robot to figure itself out. And then sometimes you think it thinks it's over here, but it's like mirrored over here, right? So, and the RFID tags would completely. I mean, if you're close enough for one, you just look at that. Oh, I'm not there. I'm there. Yeah, that'd be really interesting to check how it affects the localization. Good idea. All right. Well, I'm sorry I got a little bit out in a tangent, but for anyone else that is watching, you can do here what Brennan did to showcase what you've learned with our courses and to prove that you're actually learning in this space of robotics. So I encourage everyone that's watching to take the course and come present with us. And Brennan, again, thank you very much, and we'll see you next time for the next one.
Fantastic. Thank you.
All right. Bye-bye, everyone. Have a good time. Okay. I finished the stream.